point. There we go. We'll hop into our first session of the day. So we're going to be providing more details on the FE Neon Forecast Challenge, expanding on what was mentioned yesterday, including some brief overviews of each of the challenge themes. So I'll now hand things over to Dr. Quinn Thomas, faculty at Virginia Tech and project lead of the FE Neon Forecast Challenge. Quinn will be providing a brief intro to the challenge, followed by overviews of each of the themes. First, a few provided by Quinn, then Anna Spires of the University of Colorado Boulder, Dr. Ryan McClure of Virginia Tech, and John Foster of Boston University. Then we'll have a few minutes for questions at the end of the session, so keep that poll everywhere in mind. So Quinn, go ahead and take it away when you're ready.
Great, thanks Dave for that wonderful introduction. And I'm really excited to be sharing some more details of the Neon Ecological Forecasting Challenge that is being hosted by the Research Coordination Network within the Ecological Forecast Initiative. And this is funded by the National Science Foundation and is a joint effort between EFI and NEON. And yesterday I mentioned in my talk yesterday this challenge, and today the goal is to go into a little bit more depth. So, to revisit the charge, what we need to grow the field of forecasting is more forecasts from a diversity of perspectives and approaches that engage more partners. And that will allow us to discover what is predictable in nature and what predictions are most beneficial for society. So that's kind of the big picture view that we're approaching this effort. And kind of forecasting challenges, data science challenges, competitions, forecasting competitions, model intercomparisons. These are all kind of concepts that are floating around out there and have been applied to things like predicting beetle or penguin movements or carbon fluxes or COVID, challenges for kind of processing neon data, dengue forecasting, and then there's a whole role of forecasting competitions and challenges in kind of the business world, and kind of represented by this M5 project. And so this inspired us to think about how we can use these concepts to kind of focus the energy of the ecological forecasting community to help us move from talking a lot about it to really, trying to forecast very similar, in fact, the same things to really understand and address that challenge I presented on the previous slide. And, folks may or may not be familiar with NEON. NEON is an effort funded by the National Science Foundation to collect observations over the next 30 years that are standardized across sites of both aquatic and terrestrial processes. And what's unique about NEON is that it is dedicated to the observation, and it's up to the community to use the data. And so this is a real exciting way to use the data because NEON is taking care of we know that there's going to be future data to ultimately compare to our observations. And so it really sets up nicely this idea of, can we predict neon data that spans ecological system and scale before NEON collects it? And that was the idea that really inspired us. And because it really spans a lot of gradients, both terrestrial and aquatic, there's really a rich data set to think about forecasting different types of ecological processes. And so what is a challenge? I want to emphasize that we are using the word challenge very intentionally here, because the word competition sounds not as collaborative. And we want to challenge the community to work together to forecast neon data. And that's why we call these the Neon Ecological Forecasting Challenge. And so the goal is to predict neon data before it's collected across different domains in ecology. And this will help us explore our predictive capacities. It's a formalized process for forecasting or comparisons based on community developed rules and standards. Like the file structures, the metadata have all been worked out by this community to enable intercomparison. It's resources to support ecological forecasting and reduce barriers, such as this meeting here, such as R packages, functions, cleaning up data sets, making kind of weather forecasts available for each NEON site, trying to reduce the barrier of entry to forecast using NEON data. A means to grow the forecasting community and tackle important needs associated with standard software and stakeholder partnerships. By having a really kind of practical goal, a lot of needs will have emerged, and now we know where to focus our energy on addressing them. And it's also a positive, inclusive, supportive, and collaborative challenge. And so the idea of this common forecast protocols across ecological systems and scales, and we'll get into each of these throughout this session, but it kind of emphasizes both aquatic, terrestrial, and population, community, and ecosystem thematic areas across our 5 themes. And so the first most important resource I want to point you to is the user's guide, or the protocols. And this is available this is a book down document that's written in R but displayed as HTML, that is dynamic, meaning that we can update it. You can see the changes on GitHub if you'd like, but it highlights all the rules and guidelines for contributing to the forecasting challenge. This includes the thematic areas here, with specific kind of motivations on why that was chosen, how the raw data is converted into what we call the targets, which is the thing that you can use to train your model that will be in the same form as what ultimately how the raw data will be processed to evaluate the models. Rules about or guidelines for participation, submission instructions, evaluation, meteorology inputs that are available to drive your models if you want, helpful functions. These include some packages that have been developed to support the challenge. And then also importantly, frequently asked questions. So this is an incredible resource that we've developed recently in response to a lot of questions and feedback from the challenges that were launched earlier in the year. And so any individual or team is encouraged to join. You can join late. You can also, if you want to try different models, you can register different teams that are effectively the same people but have a different team name that signifies the fact that you're using a different model. And you can submit to all or one of the themes. So we're really flexible on how you engage. And so you have to register your team, submit a forecast either through the web interface or uploading using our functions that we've developed in the kind of the NEON forecast package, and that's all you really need to do to be involved. And so the idea is any team, any model, and a common evaluation. And so we have a dashboard. It's at shiny.ecoforecast.org, where you can click around and see the submissions that have already been submitted. And what's really neat about this is you can see how you can look at how the models that you submitted in the past compare to data as the data come in. And so, for example, here's a forecast to the phenology challenge that was submitted on, I think this is like April 2nd, before these data were collected. And you can kind of see how the forecast turned out. This data did not go into building this forecast. And it just shows you how you can go in and automatically see how you're doing after you submit. And that's really exciting, I think. And then also the common evaluation. I'll get in a little bit more to how we're scoring the forecasts, but we're using a metric that is called the continuous rank probability score. That is a metric that allows you to evaluate a probability distribution or a forecast with uncertainty rather than a point forecast. And we specifically are choosing that to emphasize that the importance of submitting forecasts with uncertainty. And the standards that are written in the guidelines for submission really, emphasize, uncertainty. You can specify it as a standard deviation. You can provide different kind of numerical ensemble members that represent uncertainty, but uncertainty is an important part of contributing to the challenge. And the score reflects that, whereby the lower score is better. And I'll get to that in a second. So the continuous rank probability score is the centralized metric that is being used. And important for this is that 0 is perfect, so lower is better. And it takes into account both the precision and spread of your forecast. For example, this is a generic kind of observation here. The value is 8. Maybe it's 8 milligrams of oxygen per cubic meter, something like that. 8 is here. Now, if you predicted, and then these contours are the score. So if you predicted 8 with a standard deviation of 4, you get a score of 1. If you predict 8 with a standard deviation of gets lower and lower and lower, your score goes to 0. But you can also score a 1 by having a lower standard deviation, but be off and not be as accurate. And that's because you're better representing the uncertainty in your forecast. You can have a really accurate forecast, but start to produce worse scores just by having larger and unnecessary spread. And so this idea of it's important to include the observations in your forecast ultimately when they're evaluated. And that's almost valued as much as an overly precise or an overly broad forecast. And so we have a lot of information about this metric, and I want folks to understand that as embedded in the forecasting challenges, both the presentation of uncertainty and the central tendency of your forecast. And behind the scenes is a cloud-based automated workflow. And I'm showing you this here to kind of understand where your forecast that you contribute can fit in. So every day we download NEON data. And if there's new NEON data that shows up, we convert it to the target data that becomes available to you. Every six hours, we download NOAA weather forecasts and we downscale them for the NEON sites. And those are made available to you. The design teams have created the scripts and null models that are being, these scripts are what converts the raw data into the target data and generates a null model. Primarily that tomorrow is the same as today. All this is occurring within kind of a container-based architecture, running our studio on an NSF server. What becomes available for you, either through clicking download or using S3 bucket commands, are the targets, the weather forecasts are available for you to then grab hold and make your forecast and then submit your forecasts and metadata back to that bucket. And either you can click on it and add it, or you can use the commands that we packaged up for you in the NEON forecast package. Those then become available to be scored and forecasted in our Shiny app that then is available to you as well to look at. And so when you contribute your forecast, it checks for new forecasts approximately hourly. If you submit a forecast that matches the metadata and file standard, it will automatically go into a folder that has all the forecasts that are contributed to that theme that then can be visualized. If your forecast does not match the metadata standard or the file format standard, it goes into a location that a directory called not in standard, and it produces a little bit of a log for you to understand why. And all the guidelines for this are available in that user's guide that I presented at the beginning of the challenge. And so this is all kind of going on behind the scenes. It's been refined by feedback from the community. And we're really kind of excited about this novel cyber infrastructure as well, that's kind of developing the automation side of the forecast. And so ultimately what's coming out of this is protocol standards and best practices for environmental forecasting that are available beyond the challenge. Opportunities for training, both through tutorials and training sessions like this, new software tools. We're engaging federal and other partners in the development of the challenges and the rules, and the submissions will ultimately contribute to a multi-forecast synthesis that will highlight patterns across forecasts. And the resources that are available for you that is still growing are pre-processed time series of NEON variables, NOAA weather forecasts at each NEON site that's available for you. And these go 35 days into the future. An R package to help you contribute to the challenge. An R package for downloading and working with NEON data called NEON Store. Example code for generating forecasts for each theme. Example code for generating model output and metadata in our newly developed standard, and a Slack channel for questions. Those are all the kind of resources that are already available, with more emerging. And I want to point you to this NEON forecast package that's available on GitHub through a GitHub download, and information on it is at the user's guide that we have developed for you. And within that are things to help with submissions, NOAA downloads, downloading of the target data, and importantly, actually generation of the metadata. I really want to point you to the frequently asked questions that are within this document. And your feedback has helped develop this. So don't hesitate to ask questions. And we'll give you your answer to your questions, but then use that to develop where the additions to this Q&A. And you can learn more and register at this website here. And so we're just really excited to have folks contribute to this, and have been really thrilled of all the submissions we've had already. And it's really been neat to see forecasts that have already been generated for the themes that started already. We can see how well they're doing. And I think it's, people have really liked the Shiny app, and it's been really fun. I want to emphasize that this first year, we're considering it the beta year. It's really helping us work through the kinks. And so your feedback is huge. Where are you having trouble? What do you want to see for next year? And subsequently also patience, knowing that there are going to be kinks in the system, and we're going to work with you on those. But it's just iteratively, people submitting forecasts helps us iteratively, work through and make it more streamlined. And the goal, since this is a 5-year NSF project, is for this to continue for the next 5 years at least. And so there'll be many opportunities to contribute once you refine your forecasting techniques. You can keep contributing year after year. So we're really excited about that.